Graham's law says that the ratio of effusion rates of the gases is inversely proportional to the ratio of their molar masses. So we need to use this law to determine the molar mass of an unknown gas, comparing the rate of effusion of the gas to the rate of effusion of the nitrogen gas, which in this case is given that is 14.65 milliliters per minute. So one important thing here is that to assign the gases correctly, which means that what is going to be the gas 1 and what is going to be the gas 2. So what we can do is we can say that gas 1 will be the nitrogen and the gas 2 will be the unknown gas X. So if we do that, we can rewrite this equation in maybe a simpler way that will help us to avoid any confusion. So the ratio of the rate of the nitrogen over the ratio of the rate of the unknown gas, so 1 corresponds to the nitrogen. Now this is equal to square rooted, so the molar mass, this time of the unknown on the top, over the molar mass of the nitrogen gas. Okay, let's write down what we have. We have that the rate of the effusion for the nitrogen is equal to 14.65 milliliters per minute. We also have that the rate of the unknown gas is equal to 9.20 milliliters per minute. So at this point, it's not to mention that it's good to pay attention to the rate. So nitrogen goes faster, so the rate of the effusion is higher than the unknown gas, which means that the unknown gas is going to be bigger, so it has a higher molecular mass. That's why it is traveling slower than the nitrogen. And at this point we can actually use this to do some predictions, but we're going to do our calculations and see if it's actually consistent with our prediction. So let's continue. Now we also have the molar mass of the nitrogen, which is 28.0 grams per mole, and we're trying to find the molar mass of this gas. Mx is the unknown. And what can we do here? So first let's do the ratio. The ratio of these two, R1 or R of the nitrogen over the R of unknown, is equal to 14.65 divided by 9.20, and so this is 1.59. Next, what we can do is we can write down that this, actually put it here, 1.59 is equal to the square root, and put this number, so mx over m of the nitrogen. So we need to get rid of the square root. So what we want to do is we want to square both sides, so this everything needs to be squared, and if we do that, we'll have that 2.52. So 2.52 is equal to mx over m of the nitrogen. So we got rid of the square root, and we can say that mx is equal to 2.52 times the molar mass of the nitrogen. We cross multiply here. The mx is equal to 2.52 times 28 grams per mole, which is equal to 70.56 grams per mole. So if we keep three significant figures, 70.6 grams per mole, which is pretty close to the molar mass of chlorine gas. And here we can see, so answer E is the correct answer. So chlorine is heavier, that's why it goes, the effusion rate is lower than the nitrogens.